list of all the derivative rules that we'll ever see? Kyrie and Gavin, are these the only derivative rules out there? No, not even close, but they are the foundation. And if you didn't get anything else from today, and all that blah, blah, blah that I just was, I don't know, who knows, maybe something was good. You at least understand that a solid foundation is important. Is that good? Okay. So, a solid foundation, here's the crazy thing. These are 6 basic rules. There are a lot more coming, a lot more forever parts coming as well of the derivatives. And then we have the anti-derivatives. But oh, how much you can do with these 6 rules. So much beyond these 2 examples that we saw yesterday. But to get there, we have to talk about rewriting. To get there, we have to talk about rewriting. Now, I'm going to make a quick point with rewriting and letter B in just a second. But do we understand letter A? Have we finished it yet? Yes or no? Nope. You are about to be faced with a scary truth today, if you haven't yet already. A scary truth today is the following. Do you want me to show you what, if this happened to be, which it probably would not be, but a multiple choice question? It'll be a little more complicated. If this happened to be a multiple choice question, can I show you what the multiple choice answer that you would need to make it match to it, meaning taking the derivative of the function? What it would look like? You ready? It would be -4 all over 3 cubed root of x. Could you get there, yes or no?
Yes.
How? Okay, go for it.
When you subtract the fraction, you would get a negative 1/3.
Mm-hmm.
And then you do the 2 times the 2/3.
Good, careful. For some of you, that is so basic and so understandable. For the girl that I was talking about with the weak foundation in math, she needs to always write over 1, because then her brain can multiply the fraction. I know it's something silly, but I'm teaching Algebra 1 kids. Like, I literally need to show that to them. So it's okay. No shame if that's you. But if that is you, write it over 1. Get that to be a -4/3. Kyle, sorry, keep going. What do you do with that -1/3 power?
You're going to flip it to -1/3 power.
A negative power means it belongs, it meaning x to the power belongs in the denominator. And what does 1/3 change into? Cube. Yeah, now some of you are like, oh, stink, we're not done yet. To be honest, in calculus, we are. Why might some of you think we need to keep going? Rationalize. We can't have radicals in the denominator, but it's a great thing in calculus. To some extent, they kind of give us grace because they're kind of like, you know what, you've done enough, just stop. To some extent, this is the simplest that this expression is because the variable is in one place. We don't really care if it's on top or if it's on bottom, if it's in a radical, if it's not a radical. Just leave it. But here's the dealio. Did you guys hear me say just a second ago, if the AP was nice, this would be a multiple choice? That means it definitely wouldn't be an FRQ part. It's definitely not gonna, it might be a part of an FRQ part, but it's definitely not an FRQ part. Which means, okay, we'd be trying to make that answer match with this. There is some wisdom, and this is really scary for me to say out loud, for you guys. Some of you are going to take this the wrong way and use it against yourself instead of for yourself. But there is some wisdom to having done a problem. And before you keep going, before you keep simplifying, before you make it whatever you think it should look like, looking at the answer in the back of the book that only works for odds and seeing if you can make it match. Meaning, if all the multiple choice answers had x's on top and x's on bottom with all the radicals only on top, okay, you should keep going. But if they have radicals in the bottom, if you keep going, you're wasting your time. Does that kind of make sense? We'll talk more about it, don't worry, this is just an introduction to that. But, long story short, who or what is the derivative of this stuff? Now I'm going to draw a quick line real quick. Yes, I know, I said quick twice. I believe myself. I do that a lot, I just don't always voice it. And I just said the word like. Anyway, I drew a whole separation line because what's the difference between this side and that side? What's on this side? Who are these guys?
Making it look nice.
I'm just making it, well, making what look nice? Careful, in calculus it's so dangerous to say it, and I know deriving it, I just used it up there. But who am I referring to with my it?
The original function.
The original function. So who are these guys? These are my, in some way, shape, or form, my f of x. Sometimes they use y, okay? Sometimes they use y, sometimes they use f of x. What's this side? F prime of x. Or if they were using y notation, some of you might be realizing this in homework. If they use y notation, they're using dy dx. And if they have an f of x, they're using f prime of x. Do you kind of see where this guy ties in with that guy? And that guy ties in with that guy? Okay, so we have the original side and we have the derivative side. And the only way to pass from here to there is by taking the derivative using our basic rules. And rewriting is not deriving yet. It's just making my life easy. And guys, here's the dealio. There is no magical rule out there that's coming that's going to make this any easier. The only way to solve a radical is by making the radical into an exponent notation and then using it out. Cool beans? Now, yesterday, and with you, we got a little bit further than period 6. Maybe I took a little more time this morning, but no, I just often don't know when to stop. But, coming back. Do you remember I said, uh-oh, division, uh-oh, multiplication, uh-oh, division? Do we have any difference, or, not difference, sorry, my bad, quotient or product properties on the page before? Mm-hmm. Now, some of you are like, oh, make up my own rules. I'm not even getting started on that one. But in calculus, no, don't. We have to have a foundation, a basis for why we do what we do. Oh, so my life lesson. Shh, my brain's just going on. Come back. So if I can't do division, can I rewrite this in a way that it is an addition or a subtraction? Yes. Now, for my kids that have had me before, I would call it the heart trick. Maybe I did it sometimes, maybe I didn't do it other times, because people haven't been learning algebra from the same teachers that used to be teaching algebra when I first started teaching calculus. But anyway, that's okay. A lot of things I do came from me using what other teachers did and then kind of incorporating it. But that's okay. It's still called the heart trick in my mind. The heart trick says whenever you have a common denominator. A common denominator? What? It's just a numerator and denominator. No, it came from two separate expressions, or it could have come from two separate expressions with a common denominator. If you have a 1/3 and I don't like that one. How about a 1/5 and a 2/5? Wouldn't we add them together to be 3/5? So if I have this expression and this expression, they would combine with a common denominator. So the same way it was put together, guess what I can do? Take it apart. If you don't like that kind of symbolism, you could also think of this expression, -5x² + 1, that's being divided by x over 1, which means I can distribute. Any division can be written as multiplication of the reciprocal. So if it works a little bit better in your head this way, you can also think division of x over 1 is like 1 over x, and then we boop, boop. There we go. So, either way, what can I change this into? My pause. Doing some calc chat, magical, moving forward. Whichever way I do it, that rewritten form would have come from simplifying. So maybe you need to show the in-between. But guys, what happens here? I can reduce that guy to get my -5x + 1 over x. But what did I do with the 1 over x? I made it x to the -1. Why? Because there is no division rule that we know yet. And even when we do learn a division rule, this way is easier. Once I have it rewritten, now are these my basic rules? Yeah, I have a sum of two different terms where each of them can be solved with a constant multiple and with the power rule. So, question, what do I end up getting here when I take the derivative of this guy? What happens to that -5? He stays. What happens to x to the understood 1? Bring down the 1, right? And that's going to be x to the 1 minus 1, which is 0. Huh. What's going to happen to this next guy? Well, I'm going to bring down my -1. Some of you aren't so good at negative numbers. It's okay, just embrace it and grow. What's -1 minus 1? -2. Here's the dilemma. Can I show you the answer that they would have in a multiple choice question? I'm going to be nice. They might have this one. They probably won't, but they might. Do you see at least where this one comes from? Because x to the 0, anything to the 0 is just 1. Poof, I have a -5 times 1, which is -5. This one, isn't that x to the second power in a denominator? There we go. Why am I saying they might not have had that one? Here's another form that they could have written, and it would have been negative 5x squared minus 1. They could have had this one. What? X squared over x squared, couldn't they have gotten back to a common denominator like the original expression has? Does that make sense? Either one's, oh no! Either one's right and they look very different, or do they? Some of you basic math, basic algebra might come back to bite you in the butt a little bit, because that sometimes might be the right multiple choice answer and that sometimes might be the right multiple choice answer. What do you have to be able to do? Make it match. Have a right expression and figure out which one's right out of the ones they give you. The hard part is if they have this one as the right answer, they're going to have something that looks like that, but just one little difference is going to make you second guess all of your life choices or at least all of your work. Or if they have it written like this, they might have something that looks very similar to that, but with one little thing different that once again, it looks like what you have. It's going to make you rethink all your work. But it might be a wrong answer and there might be a right answer. But don't worry, remember that's why the AP test says give 65% and we'll give it the highest score. Remember my tests on all of those questions. How about letter C? Is there a product rule? Not in our basic rules. Not in our basic rules. So how could we solve this? Just with constant multiple, power rule, constant, sum and difference. What would we have to do first? Yeah. And when you FOIL, can I just go there? Is that okay? You're going to end up with, after FOILing and combining my terms, oh bummer, we don't have a lot that combine. Because we have a 3x cubed minus an x squared plus a 3x minus a 1. Nothing combines. Oh well. But is that a sum or difference?
Yeah.
With terms that are able to be solved with constant multiple power rules. Yay! So therefore, my first one is going to be, well, how are you guys doing with the power rule? Bring them down. Are we okay just to go straight to 9x squared? Are we okay for the next one just to say that negative 1 times 2 is negative 2x? But the last one's going to be plus 3? Guess what? Sometimes you can't simplify. Some of you are like, oh, but we could have factored. Well, maybe. Any factors of 27 that make 2? Sometimes it is what it is and you're done. Sometimes it is what it is and you're done. How about this last guy? There's no quotient rule, at least not that we know. Or for median. Can't just do my hard trick. There's no plus or minus. That's what you should have done on the test. Oh, hint, hint, hint. That's what you should have done on the test. Tangent is tangent of t over t. So minus t goes to 0. What you should have done on the test. Tangent is sine over cosine. So what if I rewrite this to be 3 sine of x all over 4 sine of x? And some of you, basic stuff's going to bite you in the butt. It's 4 over 1, 4 sine over 1 cosine. Oh, that's not. Now I have 2 quotients instead of 1. So you can technically make this. Now, remember I was talking about like kids who's now doing calculus at Marburg that was failing algebra 2? Do you guys see that technically this would be 3 sine of x over 1 all over 4 sine of x over cosine x? My complex fraction trick she hated. She never did it and she never will. Because the way that she first learned was these guys end up being the numerator and those guys end up being the denominator. It's just the way she learned. So she kept on doing it that way. You don't have to do it that way. You could also say, well, I learned it, whatever you have. Division by a fraction is multiplication by the reciprocal. If that's the way that works, don't go confusing your brain with my tricks if it doesn't work. My way would have been multiply top and bottom by cosine. That one's gone and the cosine joins. But either way, if you do it legally, if you do it correctly, you're going to end up with a 3 cosine of x. Have a way that works. And if it's not my way, make sure you know your way and you know it really well, and then just keep going that way. And if you're like, well, I don't like your way, but I don't remember my way, come in. I've probably seen it and I can probably teach it to you. So wait a minute, hold on. That's not even the derivative, is it? No. Why am I going to come and select all of this stuff and go make it black instead of red? Who are all those guys? It's just the original function. So what do I still need to do? Take the derivative. Here's a struggle with derivatives. You ready? The derivative is so easy, but you have to know the rule. Oh, forever! It's something to memorize forever. Because the derivative of 3 cosine of x is negative 3 sine of x. It's so easy if you know the rule. You know what's a struggle? They would never just ask you that in a multiple choice.
I was right. You're missing the 4.
Oh, gracias. Why did you focus on the rule? That's a life lesson in there too, but it's okay. I do that one all the time. I can say that later. Here we go. Focus on the big things and sometimes forget the small things. Sure, why not? Here's the problem. The AP, if it wasn't a multiple choice, they probably would ask you for like f prime of pi over 2. Or f prime of 7 pi over 6. So here's the struggle. You not only need to know the derivative rule, but what else would you have to need to know? I made my point yet about the unit circle being important. You can know the calculus, and then you can get the problem wrong because you don't know the unit circle from algebra 2. Ah!
Algebra 2.
Seriously, though. All right, ready, set. What can you guys do? These are technically examples 3 and 4 because we did 1 and 2, and then we did a little like rewriting aside. You go write down 3 and 4 for it. Ready, set. You guys in your groups find me some derivatives. P.S. There is a derivative competition coming tomorrow in class with whiteboard. It will be fun. So in order to have it be fun, you need to know your rules and you need to have done some practice so that you're not just doing it for the first time.
So do some homework.
Oh, maybe you should start some homework. Come on, my competitive ones. Tomorrow will be fun if you prepare. You gotta practice to have a good game. Talk about it. Talk about it. It's okay. You don't have to do it by yourself. It's not a quiz. It's not a test. It's not the competition yet.
It looks so simple, but it's not simple. It looks so simple.
Talk about it. Talk about it. Yeah. You're seeing this for the first time, a lot of you guys. It's okay.
Now, how do you simplify that? That's 1/2. Square root is 1/2. So you have to do 1/2. Then you're going to subtract it. You're going to pull this down. And you can subtract it. It's 1x. So it's 0 2. And then you're going to do this one. Dad. This is 1.
You have 6 minutes, and I'm not doing it. And I'm solving something, and we're going right back. Yeah. Let me get your blue pen, because if you do it in pencil, they can't tell that you printed it.
You never realized that?
So right now, when you do
Oh, you can. 5/2.
Wow. My life is forever changed.
For those of you guys that can't see it, it's a 5/2. Is it? Or is it 3? Wait a minute. Hold on. Oh, that's a 3.
That's definitely 3/2, isn't
That's a
it?
3/2. Why? I'm so sorry. It looks like a 5/2. I wanted to do that. I'm gonna start playing with number 3. I'm not using red yet because I'm still rewriting.
How are you ready?
Careful, you have to label things correctly because the original is not the derivative and the derivative is not the original unless it's either x. I'm showing all of my work so that if you made a mistake, you can find it.
What is this?
I'm going to be messy for right now and not get a common denominator. Very un-AP. Questions on the first one?
Wait, so for this one, just
How did we reduce that? You just rewrote the top, right, Miss King?
The math speaks for itself because all I did is equals, right? So I haven't done any deriving because I'm still saying this is the original function.
Where did the bottom go?
Exponent rules. When I have common bases dividing, I subtract their
Oh,
exponents.
that's what it was. Okay.
So I did this guy over that guy, subtracting the exponents, and I did that guy over that guy, subtracting the exponents. So x to the 3 halves over x to the 1, and then 2 over x to the 1. You guys see how I'm creatively subtracting 1? Subtracting by 1 is subtracting by 2 over 2 just to make it easier in my brain. And I'm showing you what technically I have been doing for quite a while. I do that mental math. A lot of the kids in BC at this point can say, derivative of 10 is 1 over 2 root x, no big deal. But I'm showing for you guys all the work as to why, just in case. Once again, being very non-AP-ish in that I'm not getting common denominators, but I'm just making sure that you're getting correct derivatives. How are we doing? Second one, maybe the in-between step would be helpful of me showing my x to the 3 halves. That was technically the in-between. So then I made this 2x to the negative 1, and then technically this is x to the 3 halves and x to the negative 1. I add those or subtract those powers, and I get 3 halves minus 1 to combine my like bases. It's exponent rules. But I made the minus 1 to be minus 2 over 2, still making it easier on my brain. So this isn't a derivative, this is just me reducing like basis. That kind of makes sense. And then I got to what I could with the derivative of with my power rule. Now guys, we are scratching the surface. Not in the sense that it's going to get crazy, like way harder. It's just, you got to look at these problems in a rewritten sense. You kind of got to look at them in a different way in order to be able to do what you need to do. Does that kind of make sense? And then we have to try to simplify the derivatives, which is its own little beast. But there is something else that you might see in homework, but the nice thing is you've already seen it. Haven't we already seen f prime of a? The derivative at a, right? So if you're trying to find a derivative at a, remember we are trying to find the derivative first and then plug in. So we're not plugging into the original, we're finding the derivative first and then plugging in. This notation right here is technically saying you are finding the derivative. The derivative of a function f at a specific x equals a. So both of these, whether you see f prime of a or whether you see me do this whole such that thing, they're talking about finding the derivative and plugging in an a at the end. But you have to do derivative first and then derivative first and then put it in. If you're curious, this little line just means such that. With that, cool kids, start your homework. But if you remember, the end of these notes are examples, 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 examples. We'll do a couple just to kind of, warm up tomorrow, and then we'll start competing, which means going fast, but you can't go fast until you develop your skills. So start homework first. Develop the skills first, and then we pick up speed. Any athlete knows that, huh? All right, guys.
No one ever. I don't see you. Abby, ready for a mock dinner? We're doing bubbling doubles, but she said it's not going to be great.
Thank you for letting me borrow your head.
Come on. You should drag your back.
Can you do after practice today?
No, because we